All right. Good afternoon, everyone. My name is Arlo. I'll be moderating today. To start things off and for a welcoming statement, I am thrilled to introduce the Dean of the School of Information and the Associate Provost of the Division of Computing, Data Science and Society, Jennifer Chayes.
Hello, I am just thrilled to be with all of you. I'd like to welcome everyone to the Data Science Showcase. Every semester, we look forward to this opportunity to learn about and celebrate our students' amazing work with the Data Science Education Program. This is the first time that I'm a part of this, and I'm really, really happy to be here. One of the remarkable features of the program is the richness and depth of student engagement. At any one time, we have hundreds of students contributing to data science curriculum development and to research. We have students helping to design course materials, integrating data sets from a range of fields, from neurobiology to law to economics. We have students on our human context and ethics teams finding ways to help ensure that we embed responsible and ethical practices in our work. And we have students in the Discovery program advancing cutting-edge research partnership with researchers, policymakers, and entrepreneurs on campus and off campus. Today, we'll hear from students who are creating a hub for environmental social justice, working with NASA to investigate how different factors affect pilots' fight behavior, and developing algorithms to identify and support inclusion and belonging online. These are like really amazing topics. I'm very, very excited about these. As someone who spent decades leading research labs for Microsoft, I can attest to the value of these hands-on experiences. Employers are eager for graduates who bring not just data science skills, which of course are at a premium, but also the ability to lead, innovate, and flex with the challenges that come with real-world applications. Just think of where we are now and how the real-world applications change. So thanks to all our students for your remarkable work. We look forward to learning all about it this afternoon. And I'm going to have to warn you in advance. I have another meeting that I'm going to have to get to, but are we recording this? Hopefully.
Yes, we are recording.
So I will be able to tune in later and see the phenomenal work that you've done. I am so proud of all of you, and I'm so honored to be able to be your dean. Thank you for participating.
Thank you so much, Jennifer, for that introduction and for kicking off the event. Okay, a quick logistical note. We will be taking questions in the chat box throughout the event that we will invite our presenters to answer after all the presentations are over at around 3:10. So please submit any questions you have in the chat box and stick around to the Q&A session that will begin in about an hour. Okay, as you've heard, we've got quite a lineup this afternoon, including presentations from the groundbreaking modules group and from a number of innovative discovery projects. But before we get to all of that, we are going to begin our afternoon of presentations with the impressive Ari Edmondson and the Human Context and Ethics team. Take it away, Ari.
Hi, thank you so much, Arlo. So my name's Ari Edmondson. I'm a HCE coordinator, that's Human Context and Ethics coordinator in DSEP here at Berkeley. And I don't want to say a whole lot because I want to give as much time for our incredible student team to talk a little bit about the work they've done sort of generating curriculum relating to human context and ethics that can be sort of inputted and embedded into data science curriculum sort of across the board. And we've got lots of projects. We're going to walk you through one of them. So without further ado, I want to introduce my three brilliant student team leads. We have Ollie Downs, Alyssa Sugarman, and Mateo Montoya, who will talk about HCE broadly at Berkeley briefly, and then walk you through one of our homework interventions that we've done. So Ollie, I think you'll be doing the screen sharing.
Hi, yeah. 1 second. All right. Hi, everyone. We are so excited to bring you today an overview of what we as the HCE student team have done this past semester, and we're just so excited to be here with you today. So data science is like the heart. It's made up of 4 chambers, each crucial to the success of the organism. Statistics, computing, domain knowledge, and human context and ethics all work together to create a field of data science as we know it. Many of you here today are highly invested in one or more of these 4 big topics. Our team works with the knowledge that it's really important for data scientists to be engaged fully with all 4 of these topics. The data science education program and data science courses, including Data 8 and Data 100, and domain-specific courses all integrate the first 3 topics, and our team works to integrate the 4th, HCE, into those courses. Our goals for these classes focus on some central learning goals, touching on our impacts as data scientists on the world's impact on us, and how we work within structures of power. We bring in analytical tools and lenses from history and science, technology, and society studies like agency, context, representation, and expertise. And we use these tools in our integrations, and as we'll be presenting today. We want students to be able to recognize and take ownership of their place in the data science world and as humans with expertise and as practitioners of critical data scientists. So what does the student team do? As the human context and ethics of data student team, we work on integrating social science concepts and frameworks into technical data science courses. As you'll see, we work with course staff to shift curriculum to discuss how data is situated in the world, how we are situated in the world, and the concrete ramifications of our actions as data scientists, which is what we're going to be talking about today. Additionally, we also collaborate with the Discovery Program and data scholars to ensure HC is part of students' experience with data science outside the classroom. Through all these collaborations, we inspire students to see themselves as members of the real world, as well as go beyond the academic. And now I'll hand it off to Mateo to talk about one of our projects this semester.
Thank you, Ollie. So just like Ollie said, I think a large part of what we do in HCE is placing data in the world. So when we're learning about data science in the classrooms at Berkeley, oftentimes it's very easy to start working on the data set and forget that that data set comes from a very specific place and from a very specific time. So a lot of what we do in trying to teach students to consider themselves in the world and to place data science in the world is by asking students to wear different hats, to place them in situations that are specific enough that they can realize that there are contexts that are beyond data science that are intimately important to the work that they do. And so we're hoping to give you a glimpse today at one of the homeworks that we've done this semester, where we integrated into Data 100's linear and logistic regression material. So originally in Data 100, there is an existing homework. It's on Ames, Iowa, which is a college town in Iowa. And that data set consists of a bunch of features about like a bunch of housing features and then also the price of houses. And the goal there is to predict the housing price based on the features. So it teaches students feature selection. It teaches them, like I said, linear and logistic regression and sort of all of the ideas of reusability that are really important to core data science curriculum. And what we wanted to do was open that up and talk about the more social and ethical dimensions of being a county assessor and using this data as it exists in the world. So one of the great things that we found this past semester was in Cook County, Illinois, which is where Chicago is based. There's a new initiative by the government there, an open data initiative, where they're releasing almost all public data that they work with and also releasing the models that they use on those data to generate numbers. So that's much beyond the county assessor's office, but it also includes the county assessor's office. And we saw this as an opportunity for us to engage with the idea of being a county assessor more and to talk about the role of data science in this sphere. So yeah, moving on. So a huge part of that is giving students context. I think in a lot of ways, it's really important that students might not even know who a county assessor is. And in that case, it's really important to say, county assessors are people who go out on the ground and collect all of this data of all of these features. And they use that data in order to actually assess someone's property value, and they use that property value to assess their property taxes. So this is a very real question for people, and it is tied intimately to economics. And unfortunately, in the past, it's been tied to a history of racism and disenfranchisement. So in Chicago specifically, like this long bit of text here that you don't need to read all of it says, there's been multiple lawsuits going on about the county assessor's office and the way that they've done their practices. So in this case, the Open Data Initiative in Cook County is trying to respond to this history and say that we want to do this right, and we want to do this the right way. And the tool of data science allows us to be more transparent, to show our data, to show why we're making decisions, and to allow you as the public to critique our position. So that's a really, really powerful image that we wanted to get students to take part in and to see themselves as part of. And so that's sort of the goal that we were looking at when we originally found this data set.
Yeah, so moving on into a little more of the specifics of our homework and what kind of questions that we are asking students. First, we kind of start at the beginning of the homework, looking through the data set more specifically and giving students the opportunity to think about what does each row mean? What do all the different features in this data set mean, and how are they going to be used as we're working through a regression model? So questions like, given that this data represents houses, do you think that there are enough features and types of features to give an accurate picture of a home's value? And then asking in the next question, not to read word for word, but what do you think are columns in this data set that have been added specifically by data scientists? It gives students the opportunity to begin warming up to interpreting the attributes of this data set and leads them towards this idea of how data sets effectively black box this history of contingent decision making that produced them. And doing so gives students an opportunity to identify and reflect upon these limits and consequences, as well as risks of selecting like sensitive attributes for their model and considering their role as a data scientist. What power do they have in what features they're using when they're training and testing their models? Moving on to a little bit of a later point in the homework, once students have worked through their models and found and started kind of analyzing what they're getting, we ask the question, thinking in context of assessing houses, what does an error mean for an individual homeowner? Does knowing that this error affects people directly change your tolerance for the error? And this question kind of gives us the ability to have students reflect on potential performativity of their model, including that it may perpetuate discriminatory historical patterns that are encoded within this data set, and that as data scientists, they have the power to determine what decisions this model makes. Because as we can see from this larger case and data set on the whole, there's a very deep and rich history behind this entire data set, and whatever they do as the data scientists in this assessor's office could ultimately affect and perpetuate longer term systemic racism that we see in, Cook County. Next slide. And then one other part of this project that we touch upon is the reusable pipeline. And the reusable pipeline is something that we see a lot in data science, but it's something that in public data initiatives like the Cook County Assessor Office project, they created this reusable pipeline so that in future projects, there's this ability to use this model again in the future, but more importantly, that it's this transparent model that allows us to see, what work were they doing with this model and with this data that led to the decisions that were made in the Cook County Assessor Office. Being able to do this will be very important in the future because it gives us the ability to look at what decisions are being made and how we can, in public policy roles and in other work with data science, can kind of work towards models that are better for larger communities and less discriminatory on the whole.
Yeah, and so moving out of the questions once more, I just wanted to talk a little bit about how we created this homework and the sort of the process that we went about, because I think in a lot of ways we've grown a lot in thinking about how to create homeworks and also in sort of recognizing that this process isn't linear. So one of the biggest things is that all of these homeworks are iterative. When we found this data set the first time, even the idea of just porting it over into Data 100 wasn't for certain, and we had to do a lot of rigorous tests to make sure that the data set performed efficiently enough that it could be run on Jupyter notebooks and be used in a class that's a lower to intermediate level course. And thankfully, all of those sort of categories were met. And then the next stage was sort of exploratory. So looking at all of the different features and thinking about how best we can ask questions that produce the sort of thoughts and reactions that we want to see in students. So in that case, there's some columns in the data set like overall construction quality or site desirability that seem to be more subjective than others. And we want students to consider that and to think about, what does it mean to select certain features that might be more biased than other features, or that a human has had more chance to input error into than other features, and to recognize that in all data sets they are almost always constructed in this way, and that they have their own intricacies that need to be pulled out and considered before analysis can be run. And the last part is also just treating questions as open. So recognizing that we also do not have the final answers on, what this open data initiative is doing, what it has done, and what the consequences are. This is a really rapidly developing project. They've only done it for 1 year, and they haven't even surveyed all of Chicago yet. So as time goes on, we will also see this sort of like history be emerging as we're writing this homework, and it gives us an opportunity to go back to it and to think again about how best to represent these questions. And I think that sort of speaks to the fact that our learning objectives and our questions are developed in tandem. So we very much pull from the context and from the data set to develop our learning objectives and our questions, as opposed to letting our learning objectives dictate the questions that we ask or the data that we pull from. And another really important aspect has just been getting feedback from course staff. Every semester we've had a meeting with Data 100 course staff where we go over sort of our role and in that process, and also talk to them about their role and how we can best support them in integrating these ethical materials. And we also have opportunities to see how students respond to our questions and to see exactly what they're thinking about, which is really powerful in a way to help us imagine how to best ask these questions pedagogically. And yeah, so finally, I think it just speaks to our learning objectives, which pull again into this sort of ideas of power, agency, and expertise.
Great, thanks, Mateo. So what's next? Among our projects, we also have our work with the Discovery Program, our work with data scholars. We also publish student work and collect case studies for publication and teaching. And we also have other projects, including one dealing with Twitter and Trump, predictive policing, and the HCE of decision making. But we're most excited right now about the 2020 Undergraduate Human Context and Ethics of Data Essay Prize. You can submit any original essay or thesis chapter of anything at the intersection of data science, technology, and society. The prize is $300, and you have to submit by Monday, May 18th. And there's the bit.ly for the submission link. We're really excited to bring you this, the first HCE prize ever. And yeah, we're just really excited to have you all here today. Yeah, so questions at the end, we'll hand it back to Arlo.
All right, thank you so much, Ari, Ollie, Alyssa, Mateo, for that presentation and for the creative and essential work that you do. Thank you. Okay, up next, we will hear from Keely Takamoto and the modules crew. Go ahead, Keely.
So for the data science modules program, we're a part of an overall effort to further data science curriculum at Berkeley. So today we wanted to talk about what are some of the particularly innovative things that our students have been working on this spring semester. So our team is made up of both staff members, myself, Eric Van Dusen, as well as some undergraduate team leads who coordinate other undergraduates to actually design materials, work with professors, and get those materials in the classroom. We also want to thank our graduate fellow, Catherine Oosterbaan, who's new this semester and has been an enormous source of support. So our data science curriculum efforts came from a couple areas of motivation. One of them was a fundamental belief at the data science education program that any academic area can be enriched by data science approaches. Applied statistics, computer programming can lead to new insights in just about any domain. We also truly believe that any class can be enriched by working with data, especially at this time in our lives. There's so much data being generated, and we really think that every person living today benefits from having a certain amount of data literacy, the ability to engage with how data is used to make predictions, make decisions, and run at the background of our worlds. We're also very lucky in that there's been some amazing infrastructure and tools that have been developed to run some large data science classes at Berkeley. We use Jupyter notebooks, we work on the Jupyter Hub, and that allows students to access data science learning materials in a way that they might not have been able to before. Anybody can work on data science in the cloud using something as simple as a Chromebook. So our data science curriculum efforts can be broadly divided into 3 different categories. Today, we're going to focus mostly on the modules program, and the modules program creates short data science explorations in non-data science courses. They're often in the humanities or social sciences, and it can be as little as 1 lecture or 2 to 3 discussions over the course of the semester. We're also going to touch on coursework. So we do some work with connector courses, which complement Data 8 and take fundamental data science concepts, tools, and skills and apply them to a particular domain at an introductory level. Finally, we do some work with data-enabled courses, which are typically upper division, and take more advanced data science techniques, often including machine learning, to really get in depth on a particular domain, everything from legal studies to environmental sciences. Ultimately, our goals are, we want to engage students with computational methods, especially students who maybe have never done this before or have never thought that this was an option for them. With the modules program, we take the data science to them. We come to their classroom, we show them the applications in a field that they're already familiar with and interested in, and hopefully reduce the time and pain associated with learning data science, which we think there's not as much time and pain as there has been in the past, or that many people have conceived of in their heads. We also want to support faculty, with both faculty who maybe are not programmers themselves, but want to add a data science component to their course. We have a lot of programming savvy folks. So what a great match that we can help make their visions of a data-driven component come true. We can also work with STEM faculty who maybe do have some programming or statistics background in introducing students in their fields to the cutting edge technology or methods that real data scientists are using today. So next, we're going to talk a little bit about this semester specifically. What were some of the classes that we reached, some of the people that we worked with, and I'm going to hand it over to Alleanna Clark, one of our undergrads and our deployment coordinator for this semester. So take it away, Alleanna.
Hi, everybody. I'm Alianna Clark. I am a 3rd year data science major undergraduate, and I came on to the data science education program as a curriculum developer about 1.5 years ago for the modules program. And then this semester, I became the modules deployment coordinator. So a lot of what I do is communicate with the professors, go through final runs of the modules that are ready to be put into the classes, and then make sure everything goes as smoothly as possible. Especially this semester, we had a lot of bumps in the road with everything going online. So we were able to showcase the modules as an integral part of turning those bumps into the road into something that was really great, because it brought these programs to students from their own homes. So since everybody can get on Data Hub they were able to follow along with the presentations and still complete the modules as if they would if they were in their classes. So it was really great with also being able to have the data peer consultants online. So they switched really easily to Google Hangouts and were able to be online for most of the day for any of the students that needed help with the assignments that they were learning about. Some of these courses that we did for this semester were integrated into the biology department, cognitive science, sociology, ethnic studies, environmental science, IIS 150, MCB 50, which was immunology, Data 6, and also a Cal Day introductory notebook that we still went ahead and developed even to be presented online. These notebooks were able to reach over 1,300 students all across campus, and we had 15 that were fully created and deployed this semester. Next, we'll have on some of our team leads. So these are the people who developed these along with their teams: Elias, Saravia, Alec, and Alma, Pineda.
So hello everyone, my name is Elias. I'm a current senior studying applied mathematics and data science. I've worked with the modules team for about a year and I am a team lead. This semester I worked on Bio 1B. So Bio 1B is an introductory biology course for students. There are 700 students enrolled in this course and it's our largest module yet. This is usually a lab course. Originally we envisioned students would collect biological samples from Strawberry Creek and see if there's a difference between the North and South Forks based on biological metrics. Despite the current pandemic situation, our module was still able to work smoothly across students, and they were able to do it at the comfort of their home. They collected metrics, created a data set, and analyzed their own data. They constructed their own hypothesis, tested it, calculated a p-value statistic, and wrote their own lab write-up. We also created another module where we simulated predator-prey interactions. Students ran some experiments, for example, effect of camouflage on population size and reproduction rate, and population density dependence. Students can select various parameters, for example, population size, reproduction rate, predation rate, generations, etc., and see these different outputs. They can run this simulation based off of grass, sheep, and wolves and actually see the data produced in real time. And then I also had the opportunity to work on CogSci 1. Here we discussed the topic of facial recognition, how the brain processes it versus how a computer processes it. We also made connections between the limits of human cognition and limits of a computer. Some data science topics included dimensionality reduction, data simplification, and some human context and ethics discussions. Students answered questions such as what happens when we simplify data? For example, the widget on the right shows students to move a slider based on the number of principal components. Moving the slider to the left, all faces look the same. Moving the slider to the right allows for more distinctions, but more processing.
Hi everyone, my name is Alec. I'm a fourth-year senior studying statistics, economics, and data science. I've been with the modules program for quite a while. I joined as a curriculum developer my second semester here at Berkeley and have been a team lead for now my fourth semester. So I've had a wide variety of opportunities to work on a lot of really cool projects through the modules program. For me in particular, this Data 6 one is a particularly unique opportunity, and I think it's really interesting. And if you've been following the modules program at all in the past, it is a little bit different than what I and you might be used to, in the sense that rather than interjecting a short data science module into an existing course, we're actually creating content specifically for a data science course. And the purpose of Data 6 fits in very well with the mission and goals of both DCEP as a whole, as well as the modules program. And that's what I think makes it so special. Data 6 in this iteration and as a whole for the future plan has a goal to be a pipeline to the data science program, to give individuals better access for people who might have not had exposure to data science or to the data science program at Berkeley as a whole. And further, this class specifically is supposed to have a social science edge to try to add and integrate the ability of data scientists to work in fields of social science and create interest for individuals who have interest in social science but may have not had exposure to data science in the past. So the ultimate goal is to give these individuals and students an opportunity to explore data science and then hopefully enter them into the pipeline, joining into Data 8 and then continuing on through the data science program, giving exposure to as many students as possible. Now, the way in which we do this is by updating the current course content. Data 6 is evolving in its form from an existing course that was taught a few years ago, Data 8R. And the primary way that we are changing it to give it a social science approach, as well as to try to make the course more accessible as a whole, is to change the data sets that we're using, change them to be more applicable to the students who we anticipate taking this course, as well as more interesting and more applicable to a wider variety of students. For instance, traditionally in Data 8, as well as in this Data 8R course, there's been use of a data set of Napoleon's invasions throughout Europe, or the NBA and statistics on the games. Data sets that are simply not applicable to a wide variety of students. And while it may be applicable to many students that are currently in Data 8, if we want to gain exposure to allow other individuals who have never had access, we need to allow for this expansion and ability of different data sets to take shape. And that was the entire goal of this Data 6 project. We changed these data sets, we added in data sets regarding Spotify and music data, or housing prices in Berkeley or other California cities. And ultimately, we're very proud of the achievement that we've made in that we're creating this course content to make it more of a social science course, more applicable to more students, and ultimately helping the individuals who take this course have greater access to data science that they otherwise may not have had.
Hello, everyone. My name is Alma, and I'm a senior transfer studying applied math and data science. I've been working with the modules program also for a year now. I also started as a developer, and for the last 3 semesters, I've been working as a lead. And my favorite part about working with the modules program is definitely being able to expand a student's toolkit through these notebooks and hopefully inspiring them to pursue data science. So this semester, I worked on the latest iteration of 2 notebooks developed for Ethnic Studies 21AC. So we were able to integrate feedback from the last time that we ran the module, which was last spring. And we also included a lot more interactivity within the notebook. The course examines the policies for realignment, incarceration, and crime trends in California. And just about the module itself, we wanted to introduce basic Python as needed for the assignment and an overview of data science library functionalities. And most importantly, we wanted to make sure that these notebooks didn't add to the stress of online learning. And so we made sure that the notebooks were interactive and catered towards students with no previous coding experience, and that we provided enough support. It was deployed to over 100 students this semester over the course of 2 online recorded lectures, and the assignments were supported by discussion boards, video walkthroughs, and optional office hours that I held. So the first notebook, the module consisted of 2 Jupyter notebooks, of which the goal was to gain a clear understanding of the magnitude of prison and county jail overcrowding and the effects of realignment policies on these prisons and jails. So the first notebook focused on state prison data and served as an introduction to the environment and featured little to no coding, although it did allow for tinkering with the code via interactive widgets as seen on the left here. So what you see in this widget is the % occupation of a given prison over the course of time. The slider lets you slide through the different facilities, and the graphs correspond to dates. The dots seen in the graphs correspond to dates in which certain realignment policies were put into effect. And so the question that went alongside this widget, had to do with these realignment policies. Our intent with this first notebook was to get students comfortable with the notebook environment and learn some functions that they would later have to implement in the second notebook. So the second notebook focused on regional jail data and replicated the methods and functions that I mentioned, going being reviewed step by step in the first notebook, such that it solidified their understanding of table manipulation and graph generation, while allowing them to analyze the visualizations that they themselves created. After completing both notebooks, the goal was to have students have explored how overcrowding within prisons, data that they saw in the first notebook, influenced the size of jail populations, which is the data that they worked with in the second notebook after the realignment policies were implemented. And that's pretty much it for ethnic studies. Thank you.
And thanks to all of our leads today for talking a little bit about their work. If you're interested in knowing more about the modules program, whether it's looking at our library of past modules, at this point we have over 100 repositories of materials in our GitHub account. I definitely recommend looking us up on the web. You can find our main website at data.berkeley.edu/education, and you can also find data science modules on GitHub, where you can view all of the amazing notebooks that our undergrad students have come up with. And while we couldn't fit them all in this Zoom call for individual slides, a huge shout out to our amazing developer team. They come from all different walks of life on campus and off campus. They put in the work to reach out to other students who may not have thought data science was an option or was even relevant to them. And we are so, so very grateful to have them. So thank you all for taking the time to tune into What's New with Modules, and I will toss it back to Arlo to talk a little bit about discovery research.
Thank you, Keely, Elias, Alec, Alma, Alleanna, for all your work bringing data science to courses across campus and for the presentation today. Thank you. Okay, so as Keely mentioned, up next, we have a special series of presentations from student teams in the Discovery program. Now, Discovery is a one-of-a-kind program where students get matched into teams to complete a research project with a project partner in academia, nonprofits, government agencies, and social impact startups. Now, I worked personally with Discovery this year as a graduate student researcher. So I have seen firsthand the time, effort, and expertise that these students bring to their projects. They spend all semester diving into real-world data and stretching their data science skills into the arenas of project management and leadership. Now, of course, there was a big interruption this semester, but I was so impressed with how quickly all the Discovery teams adapted and completed a really productive semester of data science projects. We know that once they graduate from Berkeley, our Discovery student researchers will be ready to make an impact in the communities they care about because they've already demonstrated it with the work they did this semester. So we'll hear from 4 projects today that we are very proud of, starting with a talented group of individuals working with NASA. So Saad, go ahead and share your screen.
All right. Can everyone hear me? Hello? Yeah. Okay, perfect. So welcome everyone to the Cal Ames Data Visualization Project. My name is Saad Jamal, and with me are Sejal Sharma and Zoe Sun. Today we will speak to you about a data visualization tool that Berkeley students built to allow research at NASA Ames concerning pilot performance to progress further. So let's start with Sejal.
Right, so before we get into what our project is, I want to talk about how we got here. And on the next slide, we kind of have this breakdown of the timeline. So this project really started 2 years ago in late 2018 and early 2019. There was a series of 2 devastating crashes by the Boeing 737 MAX. And once internal investigations opened up, it was revealed that the Boeing engineers had, rather than providing simulator training to their pilots, they had actually just provided a 2-hour crash course on the iPad. And so as a result, these pilots weren't able to handle the situation that was presented to them in the sky. And the real reason for this was simply the lack of simulators because of how high they cost. On the next slide, we have an estimate for exactly how much one simulator costs. And this really creates a bottleneck. So Boeing could either have a lot of simulators at a really high cost and then reduce the time to train all the pilots, or they can have a few simulators, save some costs, but then have a really big time overhead for training all the pilots. As a result, what they did was introduce a software called MCAS, and that software was reading in bad data on both of those flights and actually overrided the pilots and was the result of both of those plane crashes. And so on the next slide, we have a timeline of like what NASA did to kind of combat this. So NASA teamed up with Alaskan Airlines and commissioned 17 pilots to go multiple flight simulation training. And so essentially what they did was they captured over-the-shoulder video for each of those pilots and to see how they interacted with the different situations that was presented to them on the dashboards and the flight panel. And then they also had a camera on the opposite side above the dashboard to track their eye movements to see if they were responding correctly to all the alerts and the pop-ups that were appearing. And on the next slide, we have a small, just a preview of what's about to come, but essentially the need for the data visualization is where we came in. There was a need to kind of overlay that eye tracking data onto the panel so that now you have the over the shoulder video and you can see exactly what the pilots are doing, but now you also have the eye data of how their eyes are responding to the different stimuli on the panel and how it's moving and responding to the different situations that were presented in them. And Zoe will take us through the engineering difficulties.
Yeah, next I will talk about the engineering challenges. The first and most pressing challenge was addressing the frequency mismatch. Our team created a one-folder hold, keeping the simulator data constant while the eye tracking data caught up. And the second was simply managing about 100 different variables, displaying them and ensuring that the data was synchronized. The codebase had to be designed with both time and space efficiency to ensure no single function caused the data to lag behind, and the simulation to no longer be synchronized. Our team used a web-based approach relying on HTML canvas for animation and Node.js server on the backend. And Sad will walk through the demo.
All right, so now let's actually take a look at the demo. So the user fires up a node index.js server and is initially prompted to initialize their data. The massive CSV files with eye tracking and sim data are converted to JSON objects, which can then be iterated through at 60 Hertz. When the user hits the simulator, the HTML canvas begins rendering the animations that you see in front of you, and you see a flat display of 3 key instrument panels. First is the mode control panel, the navigational display, and the primary flight display. The other panels aren't as important to animate, but the researchers want to know when the pilot is viewing the object. We can see there's 3 sources of data that can be easily viewed. On the bottom left, we have video of the actual simulation. We have the simulator data that's indicating all the different instrument panels. And on top of that, you see these circles that represent the eye fixations or the eye movement of the actual pilot. All 3 data streams are synchronized. And as the video on the bottom left indicates, each pilot participant from Alaska Airlines was placed in the right first officer seat. A Confederate pilot was placed in the left captain's seat. And after a briefing on the study, the participant flew 2 scenarios, was then given about an hour of training on monitoring, and then flew 2 different but structurally similar to the first 2 scenarios. As you can see, our team built a tool to allow us to see the eye tracking data overlain on top of the actual data in kind of a video format. So these eye fixations, the largest one represents the most recent in time, and then the smaller ones is the previous 10 fixations. Zoe mentioned previously about fundamental challenges, and obviously synchronizing the data was key in our next. Let's take a look at some of the next steps.
For the next steps, our team is in the process of cleaning up the code, improving reliability, and make sure the ARC engineers can improve upon our design as needed. After this, the research begins for the NASA scientists. They will fit in the data from multiple different experiments, investigate better flight deck design, and learn how to efficiently train airline pilots.
All right. Thank you everyone for listening. Now I think we take questions.
Okay, great. Thank you, Sajal and Zoe. That was really amazing. And so just a reminder, please submit any questions you have about any of the presentations to the chat, and we'll get to them at the end of the presentations in just a little bit. Okay, up next, we have Jennifer Grant, who has been working with the Beacon Lab in the Department of Chemistry. Go ahead, Jennifer.
Hi, Arlo. Thank you so much. Let me share my screen. All right. So I hope you'll enjoy this ride with me as I talk about machine learning in the context of satellite data retrievals. So first, I want to start with a topic that's all too familiar for us in the Bay Area, and that's air pollution. We know there are certain species emitted into the atmosphere for our regular daily activities, and the concentration of these species can have a long-term effect on climate as well as on human health. For example, one species in particular, nitrogen dioxide, or NO2, has been linked to cause respiratory issues in certain individuals. And these are the very individuals right now who are at high risk for the COVID-19 virus. So in this ever-changing world, scientists know that we need to understand the underlying trends of how we pollute the atmosphere. And this will help us create better models to understand how the climate can change and adversely affect us if possible. And this enables us to produce well-informed and better legislation around curbing human behavior in regards to pollution. So what does pollution have to do with satellite data retrievals? Well, satellite information is the one major tool that scientists use to study pollution. There are instruments on satellites orbiting the Earth that collect pieces of information such as how much sunlight is scattered back into space. And scientists can use this information in order to understand how much of a species is present in the atmosphere. But one really important piece of this transition from satellite data to quantified data is what we call a vertical profile. A vertical profile is an underlying distribution of how a species is present in the atmosphere from top to bottom, vertically. And it's so important in this process that small changes in this vertical profile can sometimes lead to drastically different outputs. So how do scientists even come up with these vertical profiles? Well, they use what's called a chemical transport model. Chemical transport model uses chemistry and meteorology to simulate different hourly vertical profiles of how a species is distributed in the atmosphere. This hourly intimacy about a species is what enables scientists to create such accurate retrievals from satellites. However, this method is very computationally expensive. There are a lot of complex differential equations involved in running this model. And just to give you an idea, to simulate only 1 day of chemistry over all of the United States at a good resolution takes about 16 days. And so our question becomes, can we use machine learning to improve the efficiency in this process? And more particularly, to answer this question, we'll be looking to see if we can predict hourly vertical profiles of nitrogen dioxide in Los Angeles and its surrounding counties. So as mentioned, we want to replace the need for this chemical transport model. We want to see if we can use only meteorological features such as wind speed, planetary boundary layer, temperature, and train a model to predict what a vertical profile for NO2 looks like in the Los Angeles County. Now, the Cohen Lab has spent years trying to simulate these vertical profiles using this computational model. So we have these to test whether or not our model is correctly outputting a good vertical distribution. And so if we can accurately do this with what we call a random forest model, which is a learning model, we can cut this entire computational time, this entire process down by a factor of 4. So how are we going about doing this? Well, we're starting small and iterating off of there. We're taking the centermost piece of information we have in Los Angeles and its greater county area and seeing if we can predict how NO2 is vertically distributed in the atmosphere in this one particular region, just given meteorological features that I mentioned earlier, such as pressure, temperature, where is the planetary boundary layer at? That's the boundary between well-mixed air and not well-mixed air. What are the emissions in the area? And what did we see? Well, it turns out that we can actually use only meteorological data and exclude the need for chemistry in order to predict how NO2 is vertically distributed in the atmosphere. I'm showing you here a static average. And as mentioned, in order to get a really accurate retrieval, we need to predict hourly profiles. Here's a subset of our data. And as you can see, the model does a pretty good job at predicting the hourly vertical profiles. However, there's obviously need for improvement. We're trying to see if we can include other features in the model to improve these predictions, such as surrounding emissions information. And ultimately, we're just trying to build a general method that scientists can use to replace the need for a chemical transport model, and using more easily accessible data, such as meteorological data, to figure out how species are distributed vertically in the atmosphere. If scientists are able to do this for other species besides NO2, like we've done here, they can reduce this entire retrieval process time from satellite data to quantified concentrations. They can cut this retrieval time by a factor of 4. And ultimately, this will help us in our major goal of helping scientists and legislators tackle pollution in a much more efficient and well-informed way. So to end here, I would just like to acknowledge, since I used a random forest model, which is made up of a bunch of decision trees, I wanted to thank the Discovery Program for this very specific decision tree. I got luckily matched to Dr. Ron Cohen, who then introduced me to these wonderful female graduate mentors. All 3 have been really instrumental in moving this project forward, and I look forward to continue working with them throughout the summer. Thank you.
Thanks, Jennifer. That was really impressive. Thank you. All right. Next, we have a group of students working with the Environmental Justice Mapping Project. Neha, take it away.
Thank you so much, Arlo. Let me go ahead and share my screen. All right, can everyone see it? All right.
All right, cool. So we're the Environmental Justice Mapping Project. My name is Chandana, and presenting with me are Neha, Hudait, Tiffany Hyun, and Zain Khan. And we can go into defining the problem. Cool, so the main societal goal this project hopes to contribute to is the concept of environmental justice, which is defined as the fair distribution of environmental burden and benefit regardless of your race or socioeconomic status. Currently, low-income communities and communities of color are disproportionately exposed to environmental hazards. And mapping is a very valuable tool to policymakers and advocacy groups since we can directly observe the disproportionate burdens on communities. There have been maps created in the past, but there has never been a tool for all 50 states with up-to-date accurate information and an easy-to-use interface, which is what we aim to create.
So next I'll be talking about some of our project goals. So first and foremost, we want to create that interactive map for all 50 states and help identify the communities that are most affected by different sources of pollution and be able to compare within each state. Secondly, we want to create a website that could display our map and also have additional resources and information on the project. We also wanted to post our cleaned code as open source so other developers could see our work. And lastly, we have a separate outreach team that works with communities to ensure that the map accurately reflects their current environmental problems. And they also work with policymakers to point them to the map as a resource when making policies. And next, Zain is going to talk a bit about our data sources.
Yeah, so looking as to where we're sourcing this data, so we're aggregating the data from a bunch of different sources as we're collecting a bunch of different indicator information. So some of those key sources are the EPA's EJ Screen tool, which is doing a similar thing with data and collecting all that data, as well as the EPA's NADA tool, which is for air toxin reports. So that really helps in our air toxin related indicators. And then CalEnviroScreen, we are using a lot of their methodology to replicate how to generate these sensitivity scores for affected areas. And the US Census Bureau is also a great help as it helps collect a lot of that demographic data that we need. And then the Colorado Department of Public Health is a great example of some of those local government websites we're using to access that state-specific data. And then one important thing to recognize, especially in a tool that's influencing policy, is the bias we get from our data. And so one of the biggest sources of bias we see is non-response bias, which is very common in census data. And so non-response bias comes from when there's a discrepancy between those who respond to a survey or census and those who don't. So we want to recognize that there are people that don't always respond to these censuses, and that can happen from low socioeconomic standing or homelessness. So we want to recognize that that data may not always reflect those marginalized groups. Thank you.
This is one of the many different examples of the mappings that we created for different states. This particular mapping focuses on the state of Colorado. So to create the data visualization, we created a tool, or we used a tool called ArcGIS, where developers can create different maps based on the data inputted. So after scraping and formatting the data that Zane mentioned earlier, we compiled a single indicator of vulnerability for each census tract. So users are able to input their address on the top left corner to find out more information about different indicators that comprise environmental justice, including asthma rates or birth defects. We also partnered with the Open Computing Facility to host this map on a website with more information and statistics about different indicators. So finally, moving on to the impact that this project has. So there are three main areas of impact: awareness, education, and policy management. So first, talking about awareness, our project allows different counties and census tracts to become more aware of their area's environmental justice indicators, more so focusing on the disproportionately high impacts of pollution on low socioeconomic and disadvantaged communities. And this transparency is especially important because oftentimes the general public may not know about the different indicators that impact them, both in a negative and a positive light. The second source of impact is education. Our tool helps to educate the general population on different statistics that impact their area the most and provides the framework needed for individuals to support their own views on environmental justice. By educating the public, we're able to build up the knowledge base of individuals as they make their own choices on where and how they live. And finally, our last source of impact is policy management. Our tool helps policymakers identify key areas of improvement in their communities so that they're able to draft policies to help their constituents. The team has launched several different outreach initiatives to help support this project, most notably supporting the Colorado Department of Public Health to help develop our mapping tool further. In the future, we'd like to work with other local governments to gain support and traction for our tool. And finally, we'd also like to thank Kelly and Adam at the Goldman School of Public Policy for putting on such a great project. Thank you, guys.
All right, thanks, Neha, Tiffany, Zane, Chandana. What a cool project. Okay, and our last discovery team is a group working to make cyberspace more inclusive. So Carlos, go ahead and share your screen.
Okay, sorry, I'm just looking for my teammates to unmute them. Sorry, Arlo, do you mind helping me look for my teammate Vivek? I can't seem to find him. If you
I got him. He's unmuted.
I'm unmuted. Oh, okay, thank you. Okay, hello everyone. So for this semester, we did research on the intersectional bias in hate speech and abusive language data sets. And our team lead is Jay. He is a PhD candidate in political science here at UC Berkeley. Myself, I'm a sophomore here studying data science and sustainable development engineering. Sarah, both Sarahs, if you want to introduce yourselves, and Vivek.
Yeah, I'm Sarah Santiago. I'll be giving the next slide. Do you want to go to the next slide, Carlos? Yeah. Okay, so currently a lot of work is being done to create algorithms that accurately detect hate speech online, and this can be really useful, especially on big social media platforms such as like Facebook or Twitter, where they're receiving a large number of reports daily for abusive behavior, and you just can't go through them all to detect them on your own. So having an algorithm that can do that for you is like super helpful. However, like not a lot of people are considering how the training data used to create these algorithms can be biased. And this bias can create a problem because if an algorithm is targeting certain groups or demographics incorrectly for hate speech, that can cause an issue because they're being moved off your platform when that's unjust and not supposed to happen. So we wanted to look into this problem more.
So the data we used was from the ICWSM 2020 Data Challenge. It was a data set of 100,000 tweets that were annotated with crowdsourced labels for whether they were abusive, whether it was hate speech or spam, or just normal interactions on social media. So two important definitions we think are abusive language, which is defined by the paper where this data is from, that abusive language is any strongly impolite, rude, or hurting language using profanity, and hate speech is language used to express hatred towards a targeted individual or group. So mostly we focused on the text data that was available with this data set, but there were also the crowdsourced labels and also the number of votes that were counted from those crowdsourcing sources.
So the thing that makes the study more different than others and the way that we wanted to approach our angle is that previous studies have focused on this data and this research are more focused on either like racial bias or gender bias. So we wanted to focus on something that's more interdisciplinary and more intersectional. So to do that, we wanted to classify the tweets by the race, gender, and political leaning and figure out what combinations of all three of those categories could lead to certain, effects and certain classifications that we may not expect. So our goal was to ultimately estimate how those language features are associated with distributions of hateful and abusive tweets.
So first we want to talk about the racial classification. So we used the learned demographic model to predict dialect proportions in the model, using the model from the paper Demographic Dialectal Variation in Social Media, a case study of African American English by Sue Lynn Blodett, Lisa Green, and Brendan O'Connor. So basically our output proportions for the model consist of African American, white, Hispanic, and Asian, respectively. But these proportions simply represent an inference of the proportions of words in the text from a demographically associated language or dialect. We do want to note that in the paper, it states that African American and white categories are most reliable due to the linguistic variation done in support with the US Census data. And that is pretty much one of the notes that we add there. So we take note of this. By basically implementing this model and identifying tweets as either being related to white aligned English, African American English, or other.
For the gender classification, I used a logistic regression model with lasso regularization using a bag of words representation of the tweet data with bigrams included. I found an open source data set which had the gender labels already there. So I could train the lasso model for classification on our own data set, which had no gender labels at all. Two separate models were trained, one for male and one for female, and both of them were binary because they're logistic regression models. And this allowed me to improve the training accuracy and increase the number of samples available because many of the tweets on Twitter are not made by specifically male or females. Many of them are made by brands or other political entities.
So on a high level, what we did with political classification was that we took a lot of tweets from Democrat and Republican candidates for the US congressional election that happened most recently in 2018. And based on those talking points, we were able to do some sort of logistic regression in order to classify certain tweets' contents as being either those leaning more Republican or those leaning more Democrat. So we were able to essentially do this for all of the tweets available based on what the content was on previous US congressional candidates. We were also able to classify tweets as personal attacks based on forum data and based on how the forum for Wikimedia voted them as abusive or not abusive. So to first start off with political leaning, to examine the effect of the intersections between political leaning along with both race and gender, we found that political leaning at the end of the day wasn't a very significant covariate, meaning that if you look at the graphs over here, it's pretty abundant that you aren't more likely to be classified as hateful or abusive with your tweets if you're a Republican vis-a-vis being a Democrat. So at the end of the day, we found out that based on what content you tweet necessarily about politics, it's not very likely that you're going to be flagged based on the content you say, but rather based on other types of things, just the semantics and the structure of your language.
So where we notice the biggest difference is when you look at the intersection between gender and race. So as you can see here, Black men and women are flagged as abusive or hateful almost 2 times more often than white males and females, whereas white males and females are more often labeled as being quote unquote normal in their tweets. This really points out that there's some sort of underlying bias in how the labelers gave their labels, because there's maybe some sort of lack of diversity or a lack of education in knowing how certain people talk and how different groups interact with each other online. And this can create a really big problem, because if this is what you're building your hate speech algorithm on, when it performs on unseen data, Black men and women can potentially be labeled as being hateful when this is not exactly the case.
Yeah, and I think in the further breakdown between female and male, we can see that Black males are the most likely to be labeled as hateful. And we found that this might be due to certain words that they use that might not be abusive or hateful in their cultural context, but are frequently labeled as hateful or abusive.
Okay, so in terms of our future directions, we want to use other variables in the data. So in the data set that we used of approximately 100,000 tweets, it consists of the original tweet, the label that it has, whether it was labeled as spam, normal, hateful, or abusive, as well as the vote counts. So that's where what Sarah Santiago was talking about the underlying bias when it comes to the labeling of the data, whether it pertains to one of the 4 categories. And our analysis and research didn't really take into consideration the vote counts, and that's definitely one of our future directions to solidify our findings. Additionally, we also want to run additional statistic tests such as bootstrapping t-strips, also to solidify our findings. And lastly, we do have a preprint in the forthcoming. We do hope to publish some of our findings, whether it's in a blog post or also the conference in which we got the data set from. But yeah, that's pretty much it. Thank you for listening.
Thank you, Carlos. Sarah, Vivek, and Sarah. Those are really striking results. So thank you for your presentation. Okay, well, I hope you all enjoyed those presentations from modules, HCE, and Discovery as much as I did. That was spectacular, everybody. Okay, we've gotten a few questions in the chat box that we'll dig into. And please continue to submit any questions that come up. So I will read a few and invite the respective team to respond. Okay. So we have a question for the HCE team. Do you see the role of HCE in data science changing as a result of COVID-19 or for any other reason? I think it's HCE in data science at Berkeley.
I don't know if Uri wants to take this one, but if not, I think that HCE at Berkeley is always changing, especially in this time of COVID. We were actually just talking about how this frame has kind of the framing of teaching is kind of shifting from kind of a physicality to this kind of virtual reality. And that's definitely not only impacting our work as we do it, but our work as the content of our work. I think my initial reaction is yes, it will change HC at Berkeley, and it is. I don't know that we know in what ways specifically yet, but yeah, I think Ari did a whole lecture on this, so if he wants to jump in, that's cool.
I can say a few things, but but this is a pretty huge conversation, and there's a lot of uncertainty hanging around around this issue. So I mean, there's one aspect which is just trying to talk about what the kind of HCE response to COVID is, how HCE perspectives can shed light on sort of the experience, or what kind of conversations we can be having about sort of COVID and what we call the datafied world. So like in our lecture, we spend time talking about a number of topics ranging from the really obvious things like surveillance, both sort of in the workplace, new ways in which technology comes to data-intensive technologies come to mediate work, including through things like Zoom, along with all the kind of privacy issues we saw coming out around Zoom initially. Right, this very platform that's really enabling us to have this wonderful event, comes with a lot of other privacy and security concerns that we need to be thinking a lot about. But there's a lot of other dimensions just in terms of how does something like this pandemic potentially resituate how we think about political authority. It really brings into, I think, into a new kind of light for a lot of people who don't think a lot about it, the particular role and power of the state in reordering everyday life, what we would call kind of the biopower or biopolitics of the state. And how is that going to shift right now in the balance between kind of political state power and corporate power? So there's just a handful of questions that we started to look at. As far as how it's going to impact HCE at Berkeley, yeah, I mean, Ollie touched on a lot of the uncertainty there. We have to think a lot about how we move, for example, Data 104, our main HCE course at Berkeley, how that's going to be affected potentially in the fall if campus remains largely closed down. So looking at possibilities of moving it online and what we can do there, because a really valuable piece of that course is really the human contact that we try to provide, the really strong role that GSIs have in teaching that course and providing kind of that direct human contact with students that they often don't get in a lot of their other courses. And that's very different when it's mediated over the camera. There's a lot of sort of levels of comfort and ability to interact that I think are lost. And it was hard to tell even this semester because our GSIs got to know the students early on in a real person setting, which I think probably helped the transition to an all online. So yeah, there's a lot of things we'll have to wait and see. Curious if any of the other HCE people here have any thoughts they want to weigh in on, but.
Well, great. Those are great answers. Thank you, Ollie and Ari. Okay, we have a question for the modules team here. Do you all have a favorite class that you've worked on as a part of modules?
Good question. And I think I'll unmute some leads because they've definitely had a lot of experiences in a variety of areas, especially as Alec's graduating and I looked over his list of historical courses. It is broad.
Yeah.
So Alma, did you have a particular opinion on this one?
I think my favorite course that I've developed for was one that I didn't even know existed until I started working with them, but I found it to be like a very, very cool course just in general. And the modules that we were working on were, I think, really interesting in that they obviously like took into account content that they were going over in the class, but the modules themselves were very interactive and I don't know, they were just very spicy. And I think that course, it was LS 22. I really enjoyed developing for that course.
Yeah. Just to add on to courses that I liked, I think my favorite one is probably a rhetoric course. It's a fall program for freshmen course designed as an R1B. And what we did was we analyzed political speeches and tried to determine whether it was given by a Republican or a Democrat based on the types of words that they used. And I think it was a really interesting introduction to data science for most of these students. And I think really follows the core ideal of modules, and that this is a course where no one needs any introduction to data science to get through the course, but several students left with a demonstrated interest in data science and definitely went on to take classes like Data 8. And so for me, that was an impactful performance of class just because of how that happened, because that's how I entered the data science community, because I didn't have any idea before I came here. So that was the most impactful for me.
For me, I think my favorite one was probably an MCB course. It was an upper division course called MCB 163L. It was very technical. Students got to work with an API that mapped projection densities and see like from what part of the brain connected to what part of the brain. And it was really interesting, and the professor even allowed me to see a human brain in real life that she had stored. So yeah, it was really technical, and it was interesting to see all the data science applications through their lens.
Cool. And William's in here too, so let me know if you want to share as well, because I know you've been observing.
I think, honestly, probably going to tag along with what Alec was saying, that my favorite project was, because I've done 4 of these now, and helped with a couple others. And I really thought that the rhetoric had a really good balance of introducing students to data science in a context where the material felt relevant to them. And I think that that kind of direct engagement with the course material is super valuable, where I think a focus for us is trying to really integrate the data science aspect into the course material. And so I really appreciated the way that rhetoric did that by having it be really focused on the rhetoric of these speeches, which for a rhetoric class was super valuable. So I think that was, in terms of its output, I think that X Rhetoric R1A was probably my favorite, just because I thought that it matched with the product that we created, matched with the overall goals of the course so well.
For sure, yeah, I find some of those humanity classes to be incredibly rewarding, because I'm also in the boat. And I think that's true for many of our modules undergraduates, where we didn't necessarily come to Berkeley intending to be data scientists, or for many of us having ever taken a coding class or statistics class before. So part of what draws many people to the program is the ability to give other people that same experience. Thanks for the question.
Great, thanks for your answers, everybody. It's incredible how much you've been able to accomplish throughout your time with modules. Okay, we have a question here for the NASA Discovery team. It's a 2-part question. The question is, do you know if pilots will get to see their results on your dashboard? And what other planes does your simulation work for? Saad, maybe you can take the first crack at this.
Sure, hello. I guess I'll answer this question. So first, whether pilots will be able to see the dashboard. I don't think that's in the intention, but what the pilots will receive is kind of like a score. And the score will kind of rate them on how they performed in the simulation. The second is, what other aircraft does the simulator take in? I'm not sure. This given simulation was the Alaska Airlines Training Center in Seattle. So I'm confident that they have quite a few airplanes there, or simulators there.
Great. I mean, what an incredible tool you all have built. I know it's going to make a big difference for all those pilots. Okay, we got a question for Jennifer Grant in the Beacon project. Jennifer, what other air pollution species can your work be applied to? And maybe you can explain what a species is in this context.
Yeah, so for example, NO2 is one species we're looking at in this project. And that's a really good question. So we were able to accurately or very well predict the vertical profiles of this one particular species, NO2, because of different properties it has, like its lifespan in the atmosphere, how long it lives there, and what factors affect its lifespan. And those same features or factors that affect this for NO2 may not be the same for other species such as carbon dioxide or methane, which I don't know too much about, but the whole goal was to test a method to see if whether or not, if scientists can find more easily accessible information to predict the concentration or the vertical distribution of these species, and get rid of the need for the chemical transport model. So ours worked really well for NO2 because we found some great features that heavily influence and affect NO2. And so it's up to the scientists to figure out what are some more readily available features that they can find that affect a species they're interested in, and see if they can use these features with machine learning to predict these vertical profiles for them in their particular purpose. But good question.
Thank you. Yeah, it was a great explanation of a complex topic. So thank you. All right, let's take a question for the environmental justice mapping team. The question is, what sorts of specific policies do you think your tool will provoke policymakers to consider?
If no one else on my team wants to take this, I can take it. Okay, I'm gonna take that as I'm gonna answer this question. So the really unique thing about our tool is that we modeled this off of Cal Virus Screen that has a lot of different indicators within it. So for example, I mentioned asthma rates, birth defects, so on and so forth. An interesting thing that I found, like as I was delving into this data, was that there was a lot of data that I didn't realize was out there, specifically in my hometown. So for context, I live in Southwest Virginia, and I would like to think that I live in a pretty like environmentally friendly area. However, I realized that the asthma rates in my hometown are extremely high, which is something that I never really thought about. And as I was delving more into the data, specifically in Virginia, I noticed that there was also a lot of discrepancies with what I learned in school versus like what the data is actually telling me. So I reached out to a local delegate of mine named Chris Hurst, and he was able to shed some more insight as to like what was going on with those environmental policies. So actually the Virginia House of Delegates right now is currently trying to fight something called it's called like the pipeline, which is essentially a pipeline to be placed in areas such as mine to like deliver oil, so on and so forth, which is very, very not environmentally friendly. So this data and like this map visualization tool was able to try to support policies such as trying to get rid of the pipeline to try to help to promote a more ecologically friendly and environmentally friendly place overall. That's just from like my personal experience.
Wow, what a powerful example. That was great, thank you. Tiffany, I don't know if you wanted to take a crack at that question as well.
I guess just in general, since our map, our goal is to have it for all 50 states. Our goal, I guess, it would be to be able to work with communities so that we then identify the environmental problems, not just that we see in the data, but also that they feel like they're experiencing, and try to see if, we can provide evidence for that through our map so that we can help them provide for their case, like for policymakers, and create better policies. So I guess our map is to help create policies that really are diverse, because it's for all of these different counties. And so, yeah, not just one particular policy or anything like that, but it's like very specific, as Neha pointed out.
Well, what a great tool, and I can't wait to see where this project goes in the future. So thank you all. All right, I think we have time for one more question here, and we'll pick one for the Inclusion in Cyberspace team. Okay, the question is, what can we do to make sure data sets are less biased in the future?
Yeah, I could take this one. So basically, I feel like bias is introduced either explicitly or implicitly. In terms of data set, that's a very profound question that it's pretty difficult to understand. I mean, I've even delved into that question more and helped through my HCE class that is led by both Ari and Margot. And so definitely I've delved into that question. I don't know if any of my teammates want to answer it more, but I feel like sometimes it just happens for the most part implicitly, and there's usually not much you could do to control unless everything is just objective information. But even then, you could still have slight errors that introduces bias. So that's definitely a really tough question. But yeah, I don't know if any of my teammates want to help.
Yeah, I mean, I think that like it can always help to have diversity in who is looking at the data and who's collecting the data, because or at least how I was connecting this is to how a lot of people there's a lot of issues with facial recognition algorithms, and how people are saying that their training data isn't diverse enough. And so that kind of can come into play with ours as well, because if there's just not enough people who are labeling these tweets that have a diverse background, they just won't simply know what to label different things as in the context that it's in. So I just think that that can really help when you're compiling these data sets.
Yeah, and I think I said a little bit earlier, but the context of where certain words are used is really important. Like in a cultural context, a word might not come off as abusive, whereas like in some contexts it might. So I think it's really important to continue to look into that, like being able to process text as a whole rather than seeing individual words will be really important.
Great. Yeah, thank you. It's such important work. So thank you for working on that. Okay. Well, with that, we will wrap up the Spring 2020 Data Science Showcase. It's been an unprecedented semester in so many ways, and I am so glad that we were able to come together today and be reminded of the passion and talent of the students in our community. So thank you all for coming today, and we will see you in the fall. All right, thank you.